So I'll be giving an overview of our current missions basically and our long-term plans as well. Okay, so already for some time we have always strongly supported and we continue to support the establishment and continuation of operational capabilities for SST within our framework of Copernicus. So currently we have that you're probably most familiar with, we have the Sentinel-3A and 3B mission flying in orbit with our dual-use SST capability from the SLSTR instrument. We're managing this co-jointly together with EUMETSAT. Then we are planning now and preparing for the 3C and D units to replace the A and B units currently flying. So the S3C launch is planned for 2025 in our Copernicus long-term scenario plans, and 3D will replace then the B unit afterwards in 2028. Then at the same time, we're also now starting to develop the Sentinel-3 next generation, basically, so that's the follow-on continuity from Sentinel-3 at the moment. And there has been an ITT issued for the phase A that has just been released in October 2023, so to start also consolidating the mission requirements for that. A mission advisory group has been established now also this year in mid-23. This is starting to hold regular meetings. This is being chaired by my colleague Paolo Cipollini. And I'll be giving a presentation on the mission also later on Thursday on his behalf. There are two science support studies that are running and supporting the consolidation of the mission requirements. And one of the objectives also of the mission is really to fully maximize the vis-near and thermal qualities from the two instruments that we have on board. So basically the AOLCI, so this is the Advanced Ocean and Land Color Imager, and the ASSLSTR, which is the Advanced SLSTR, basically. Now, in addition to that, just the last bullet on that page, also there we have two more missions coming in the Copernicus framework. So basically this is the LSTM mission. I will be presenting this also on Thursday. It's a land surface temperature mission. And the SIMMER mission, so that's a microwave radiometer. So this will be presented in a bit more detail also by Jakob in terms of the algorithms. These are both now in phase B2CD. And LSTM is a high resolution, about 30 to 50 meter LST product mission, and we will be providing acquisitions of the coastal zone, whereas the SIMMER mission is going to provide a resolution of about 15 kilometers of the footprint size. And particularly worth of note is the ULED design, which is a development of a large SIMMER deployable reflector of about 7 meter dimensions. So this is quite an innovative mission design. Now to put the missions into the overall Copernicus context, so you can see here our current generation Sentinels that are flying at the moment. In yellow are the ones which are basically relevant to SST. So this is Sentinel-3A and B, and then to be replaced by the C and D units. So basically at the moment we have the optical and the altimeter payloads on the same platform. This is going to change in the next generation, where basically the Sentinel-3 altimeter platform will be a dedicated mission by itself. And we then have a dedicated optical platform that will carry the AOLCI and SLSTR instruments. And then, as mentioned, we have the Copernicus expansion missions that were basically 6 missions that were identified to monitor further key elements to study environment and climate impacts. And there the two relevant ones are, again, as I said, LSTM and the SIMMER mission. Now, if we turn to the Sentinel-3 next generation, our plans for that basically are to provide a continuity of what we're doing already basically now in SLSTR, which in itself is a continuity of the ATSR instrument already launched in the 90s on ERS-1, then followed up by ERS-2, NVSAT with AATSR and SLSTR. So SLSTR is already quite a mature design. So ALCR will more or less follow a similar design, also with a dual view. It will be slightly enhanced, however, because we will provide a 500 meter resolution instead of the 1 kilometer. And we will be adding some more bands also, so there will be in the visible bands, we will be adding a 440 nanometer band in support of AOD retrieval. Then a shortwave infrared band at 1.24 microns for also improving our atmospheric correction as well as other parameters. And we will be adding one of the two bands in the thermal part. Most likely it's the 8.7 micron channel that will be added. So it's a choice between the 4 to 4.05 for the 8.7, but to support the retrieval of this SST, 8.7 is the one that is currently being favored in the emission advisory group. Now LSTM, so this will be presented by me a bit more in detail on Thursday, but it's just to give the key factors or key parameters of the mission. It's a spatial sampling distance of 50 meters. Then we have a swath of 687 kilometers. We have 5 thermal channels, 4 vis and near channels, 2 shortwave infrared, then an NEDT of better than 0.15 Kelvin, what we aim for, and an absolute radiometric accuracy of 0.5 Kelvin. Now the SIMMER mission, as said before, it's got this large reflector design there. It's a multi-channel instrument at L band, C band, X band, K and Ka band. And the SST is aiming to be resolved with about a 15-kilometer footprint with a total standard uncertainty of 0.3 Kelvin, aiming for a sub-daily coverage of polar seas. So just to give a quick summary basically of this, so our main legacy of the Sentinel-3 SLSTR for operational and climate quality SST is being continued and enhanced then with the 3 follow-on missions, which is the next generation ALSTR to provide SSTs at 500 resolution, then LSTM high resolution in the coastal area up to 100 kilometers off the coast that we acquire within our acquisition mask, and then SIMMER and all-weather SST from passive microwave. Okay, and this concludes our mission perspective for the next years.
Thank you, Mr. Thanks so much for